Welcome back to the Deep Dive. You know the drill. We take your sources, articles, technical analysis, and deep historical context and transform them into the essential knowledge you need to be truly well-informed. Today, we are strapping ourselves into one of the most debated and desired sports cars ever produced. A mid-engine legend that proved Ferrari could build perfection without a V12.
A big deal at the time.
A huge deal. We are diving deep into the engineering, dynamics, and, let's be honest, the sometimes heartbreaking ownership reality of the 1971 Dino 246 GT.
It's an iconic deep dive for sure, and it focuses on a car that, it fundamentally changed Maranello's DNA. We're going to be looking at how this mid-engine marvel set new standards for road handling.
Right.
Why its V6 howl is still, revered today, and what lies beneath that impossibly beautiful Pininfarina skin.
And that's the key part, isn't it? The fragility, the things that any owner or even just an enthusiast has to understand.
Absolutely. It's a story of design triumph set against some pretty profound mechanical and, material challenges.
Okay, let's unpack this car. To truly appreciate the machine, we have to start with the emotional context that brought it into existence. And this is where it gets really interesting.
It's a very personal story.
So this car doesn't just represent a product line, it's a living memorial. The sources all highlight that the Dino marquee itself is a deeply personal tribute from Enzo Ferrari to his late son, Alfredo Dino Ferrari.
Yeah, and that emotional bedrock is it's crucial for understanding the entire project. Alfredo tragically passed away in 1956. He was only 24 from muscular dystrophy. Incredibly young. But before his death, he was instrumental in developing the very V6 engine concept that powered Ferrari's race cars and then, eventually these road cars.
So Enzo naming the entire sub-brand Dino after him was...
It was a profound way to honor his son's legacy, his contribution to that racing technology.
So every time you see a Dino, you're looking at a piece of deeply felt family history. But, and this is the weird part, this legacy wasn't allowed to wear the main Ferrari badge at first. And that tells us a lot about its initial mission, doesn't it?
Absolutely. You have to remember the context of the era. Historically, Ferrari reserved its primary badge, the sacred prancing horse, for one thing and one thing only.
V12s.
V12 engines. The V12 was Maranello's ultimate calling card. It was their definition of uncompromising performance.
So the Dino, then, was deliberately positioned somewhere else. It was almost like a separate, kind of lower-tier brand.
Precisely. It was intentionally marketed without Ferrari badges at first. It was meant to be an entry-level sports car, something to appeal to a wider audience, which was a new thing for the company.
Right.
And that strategy allowed Enzo to protect the exclusivity and, the prestige of the V12 models, while at the same time exploring new and potentially risky technical ground.
And that risky ground was the mid-engine layout. It had dominated Formula One, but for the road, it was still considered tricky.
That's right. And crucially, the Dino 206 GT, which came before the 246 GT, holds the title of being Ferrari's very first mid-engine production road car.
Enzo was famously a big conservative with road cars, wasn't he?
He was. He worried that average buyers, might not have the skills to handle a high-powered mid-engine car if it wore the full Ferrari badge. So the Dino was kind of the perfect stealth bomber, a test case.
It let them introduce the whole concept without risking the V12's pristine reputation.
Exactly. But the enthusiasts, they knew. They quickly recognized the true Maranello heritage under that subtle branding.
That distinction is fascinating. It proves the DNA was always purebred race car, no matter the marketing. Okay, so let's look at the technical shift from that first car, the 206 to the 246 GT.
Right. The evolution from the 206 to the 246 is a classic tale of engineering idealism meeting, commercial reality. The original 206 GT from 67 to 69 was technically the purer machine.
Purer how?
It used a light all-aluminum body and an all-aluminum 2.0-liter V6, making about 178 horsepower. It was light, it was nimble, and it was hugely expensive to build.
And the production numbers show that, right? Only about 152 units of the 206 GT were ever made. That's tiny.
It's minuscule. And it clearly signaled to Ferrari that if they wanted this car to be a commercial success, a higher volume seller, they needed to find ways to cut complexity and cost.
And that need for higher volumes, numbers they'd never seen before, drove the compromise that became the 246 GT in 69.
That's the key trade-off. The model evolved into the 246 GT, gaining a larger, more powerful 2.4-liter engine. This engine, now slightly detuned for durability, delivered 195 horsepower for European spec cars. But significantly, the body construction shifted,
From aluminum to steel.
primarily to steel.
Hold on. If the 206 was praised for being so light, was switching to steel and cast iron for the engine block, which added something like 400 pounds, was that really a step forward? Or was it just a concession to the accountants?
That is a brilliant question, and it gets to the central debate among collectors today. It was absolutely a trade-off, and it leaned toward the commercial side.
I thought so.
The shift to a steel body and the heavier cast iron block, though the cylinder head stayed aluminum alloy, was done to save on production costs and make higher, more repeatable production possible.
But there had to be an engineering justification, too.
There was. The justification was that the heavier cast iron block offered increased structural rigidity and durability. It allowed the engine to better manage the demands of sustained high-performance road use and, expected longevity.
So the extra durability was seen as necessary for a car that was going to be sold in bigger numbers, driven harder, and maybe owned by less meticulous customers than the 206.
Precisely. It was a conscious choice. They prioritized robustness and accessibility over the ultimate expensive lightness of the 206.
And it worked. Commercially, it was a spectacular success. Over 3 and 800 Dino 246s, coupes, and the GTS models were built through 1974.
A huge number for Ferrari back then.
Okay, let's move into the specifics of our focus here, 1971. This is a really important point in the 246 GT's life because it marks a serious shift in production refinement.
It does. The 246 GT production ran from 69 to 74, and historians and collectors group them into three distinct series, L, M, and E.
LM and E.
And 1971 was the critical moment. It's when they transitioned from the very short-lived M series directly into the most common and refined E series. This continuous running refinement is classic Ferrari, always tweaking, always improving on the fly.
So for the listener, why do these series letters L, M, E matter so much? Is this just trivia, or does it genuinely affect the car's originality, parts, and I guess value today?
Oh, it's far more than trivia. It's a critical dating tool, and it can massively impact value and part sourcing. Each series introduced specific identifiable changes. The early L series cars, for instance, are quite distinct from the later ones.
But what set that L series apart, the one just before 71?
The L series from 69 through 1970 had those distinctly old-school racing features, like knockoff spinner wheels that you need a hammer for.
Right, the classic single nut wheel.
Exactly. And inside, the headrests weren't part of the seats. They were mounted on the rear bulkhead behind you. And externally, the front bumpers went all the way in to meet the grille.
Okay.
They also had an external button to pop the trunk.
Then came this brief transitional model, the M series. Highly sought after, right? Because it's so rare and has this mix of features.
The M series, built for just a short period in early 1971, was a bridging car. It kept some of the earlier looks, but got some vital upgrades. Crucially, Ferrari switched from those temperamental knockoff spinners to standard road wheels with 5-bolt fixing.
That's not just for looks. That's a move towards standardization, easier maintenance.
A big move for a production car. And the interior changed too. The M series introduced headrests integrated directly into the seats, a big safety and comfort upgrade. The trunk release moved inside the cabin. But maybe the most significant change was to the chassis.
What did they do?
Ferrari increased the rear track width by 30 millimeters.
30 millimeters?
Mm-hmm.
That's not insignificant. That would definitely alter the stance and, I assume, the handling, right? Make the rear end feel more planted.
Absolutely. And that physical change required modifications to the engine and gearbox internals as well to make sure everything lined up. It showed Ferrari was learning lessons from the L series and enhancing stability, especially for high-speed use.
And the M series is so rare because it was only built for a few months.
Exactly. Which brings us to the most common one, the one most of us will actually see today, the E series.
The E series, starting in 71.
Right. It began right after the M series, around early 1971, and ran through to the end of production. It's by far the most numerous version. It took all the structural and safety changes from the M series, the 5-bolt wheels, the integrated headrests, the internal trunk release.
Were there visible differences between a late M and an early E? How could you spot an E series car?
There are several subtle clues, especially on the outside. For left-hand drive E-Series cars, the windscreen wipers changed how they parked. They moved from crossing in the middle to resting parallel, parked over to the right.
Oh, that's a good detail.
Also, look at the front bumpers. On the E-Series, the quarter bumpers at the front finish noticeably short of the grille opening, unlike the L-Series cars. And finally, the door lock barrel was repositioned slightly below that distinct door scallop line.
So those tiny visual cues, the wipers, the bumper ends, tell a collector exactly when and how that car was built. That is a remarkable level of continuous engineering improvement for that era.
And this E-Series provided the foundation for the later GTS model, the one with the removable targa roof, which came out in '72. But no matter the series, the true soul of the Dino is what's tucked right behind the driver.
Let's talk about the heart of the machine. The V6 engine is the reason the Dino exists, literally. It's defined by its transverse mid-engine 65-degree V6, known as the Tipo 135 CS.
And this is a powerhouse of sophisticated race-derived design. It uses chain-driven twin overhead camshafts per bank, that DOHC setup, which gives it precise control and helps it rev so high.
It's got a 9.0.1 compression ratio, and the total displacement is 2,419.20 cubic centimeters.
Very specific.
That 65-degree V angle seems specific.
Why not
a more common 60 or 90 degrees?
That 65-degree angle was absolutely intentional, a piece of packaging genius, really. It was chosen specifically to allow the entire induction system, the carburetors, and airbox to be mounted efficiently within the valley of the V itself.
To keep everything low and compact.
Exactly. This clever design minimized the overall engine height and contributed directly to a lower center of gravity for the car, which, as we'll get to, is everything for mid-engine handling.
Okay, let's go back to that material choice we touched on earlier, the compromise. From a pure aluminum engine in the 206 to this heavier setup.
Yes, the 246 GT makes that crucial shift. While the 206 had an all-aluminum V6, the 246 uses a cast iron block for the main structure. And this was, as we said, driven by the need for more rigidity and durability for higher volume production.
Did using cast iron affect how it managed heat? Because we know these engines run hot.
Well, the primary heat management parts, the cylinder heads, remained a silumen alloy. This was a necessary balance. The heavier cast iron provided the robust, durable base you needed for longevity, but the aluminum heads kept the lightness where you needed it most for efficient heat dissipation and responsive valve action.
A well-engineered compromise. All right, let's talk power. What are the raw numbers this V6 produced?
The V6 delivered a claimed 195 horsepower at 7,600 RPM for European spec cars. But you always have to note the difference for US spec cars.
Of course, the emissions regulations.
Exactly. Early emissions rules required power sapping tweaks so that output dropped slightly, usually to between 175 and 180 horsepower.
And how was the fuel delivered?
Fuel delivery was handled by a glorious bank of 3 twin-choke Weber carburetors. The 40 DCM F7 or F13 models, depending on the series. This 3-carb setup, mounted perfectly in the V, is instrumental to the engine's character. It gives it that amazing throttle response and that signature induction roar.
In terms of actual road performance, the Dino was fast, but maybe not a drag strip champion.
Right. Its 0 to 60 time was competitive for the era, around 7.1 seconds, and its top speed was 146 miles per hour. While later V12 Ferraris and some of its rivals would boast lower 0 to 60 times, the Dino's power delivery was way more refined, and the handling made that speed so much more usable.
So it wasn't about raw acceleration, it was about the whole experience.
The totality of the experience, and the most important part of that totality, the noise.
The sound. It's legendary.
It's non-negotiable for Dino owners. At low revs, say around 3,000 RPM, the engine is described as crisp and smooth. It's got a pleasant, flexible pull. It's cooperative, easy to manage in traffic.
So it's not an on-off switch like some high-strung Italian engines.
Not at all. Not below 3,500 RPM. But the moment the driver pushes past that threshold, the character changes completely. That's when the engine truly comes alive, climbing onto its cams.
And what does that sound like?
The sources describe it as almost spiritual. The engine produces a glorious, savage, metallic barking or howling from the exhaust as it nears that aggressive 7,800 RPM redline. It's a full-throated metallic opera right behind your head. It defines the visceral signature of the mid-engine experience.
So that 3,500 RPM shift point is crucial. It means you have 2 distinct personalities in one engine. A pleasant tourer and a track beast waiting to be unleashed.
And that versatility is key to its enduring appeal. But there's an interesting detail. Sources note that above 110 miles per hour, the high-speed engine noise actually fades relative to the wind noise, making it a surprisingly quiet, fast tour on an open highway.
It balances the drama with refinement. And getting that power to the ground requires a robust drivetrain.
The V6 sits transversely and is mated to a 5-speed manual transmission, all synchromesh. Uniquely, this whole unit is located below and behind the engine's wet sump, creating a very compact integrated powertrain that helps with that low center of gravity.
We mentioned earlier that classic Italian manuals have a reputation. Did the Dino inherit any of those idiosyncrasies?
It did inherit the famous quirk. The transmission is described as precise, crisp, and direct once it's fully warm. However, a common characteristic of pre-1990s Ferraris is that second gear can be famously stiff or recalcitrant, especially when the gearbox oil is cold.
Ah, the classic crunchy second gear.
Owners learn the ritual. You need patience and gentle inputs until the drivetrain fluids get up to temperature. It's a mechanical signature of the era that owners just accept. A reminder you're operating a high-precision, temperamental machine.
Okay, so the genius of the Dino lies not in the horsepower number, but in how it uses the power it has. The mid-engine architecture is where this car earns its reputation.
This layout is everything. By placing the mass of the V6 centrally behind the driver but ahead of the rear axle, the Dino achieves a terrific, near-perfect weight distribution. That's the core of its handling reputation.
And that balance results in steering that is highly communicative, light, and precise at speed.
And it uses a responsive rack and pinion steering system, which gives the driver direct feedback from the road. It requires about 3.1 turns lock to lock, which is pretty quick. It's definitely heavy at parking speeds. But as soon as you're moving, that lightness and precision just take over.
Let's talk about that unique feeling when you drive it hard. The sources say the car tightens its line when accelerating through a corner. For the listener, what does that actually mean, and why is it so special?
That phrase is the ultimate compliment for a mid-engined car. In a typical front-engine car, when you accelerate hard mid-corner, the car tends to push wide. You get understeer.
Right.
With the Dino's rear-biased weight, as you accelerate, the weight shifts and loads the rear tires, which are right there in the center of the car. And this loading creates a slight, powerful pivoting effect.
So the acceleration itself becomes a tool for steering the car.
Exactly. The car subtly pivots inward, increasing stability and grip mid-turn. This characteristic makes high-speed cornering feel both faster and, paradoxically, more relaxing, because the car is actively working with you, following the line you set with increasing confidence.
That nimble feel is what makes the Dino so rewarding on a winding road. Now, what about the suspension? Because great handling often comes at the expense of comfort.
And that's where the Dino pulls a genuine surprise. It reinforces its status as an excellent road car, not just a bare-bones racer. The suspension uses a sophisticated independent layout with unequal length wishbones, coil springs over telescopic shocks, and anti-roll bars front and rear.
But how does that translate to the driver's seat?
The ride is universally described as superb. Ferrari designed the Dino with unusually long spring travel for a sports car of that vintage. The setup is configured to soak up bumps, to absorb road imperfections, rather than transmitting every jolt through the chassis.
So it stays stable and composed, even on bumpy roads.
Exactly. It's a remarkable balance between sporting stiffness and touring comfort. A fantastic long-distance machine.
But no car, especially a mid-engine one, is without its limits. We need to talk about the physics when you push past them.
Right. The rear bias weight distribution, while the Dino's great strength under power, is also its specific vulnerability. Because so much mass is concentrated at the back, the front wheels are relatively lightly loaded.
And what's the consequence of a lightly loaded front end?
If the front wheels hit a slick surface like water or gravel in a tight bend, they're prone to skipping or sudden, significant understeer. Since the front tires lack that weight pressing them down, the steering can suddenly lose communication and the car will try to run wide.
So it demands a light touch from the driver in tricky conditions.
It does, but there's a counterpoint. The rear stability is immense. If you back off the throttle hard in a corner, which is a recipe for a spin in some cars, the Dino typically only produces a gentle, trusting drift of the tail, a power-off oversteer.
So it's progressive and forgiving, not violent.
Exactly. The driver learns to trust it, knowing the grip is tremendous until the absolute limit.
So manage the front end carefully, and the rest of the car will be remarkably cooperative. Okay, finally, let's bring this incredible machine to a stop. What about the brakes?
Stopping power is excellent for the era. It comes from servo-assisted ventilated discs on all four wheels. And we see another production refinement here. Early L-series cars used Girling brakes, while the later M and E-series models moved to 8 components.
And how does that system feel in practice?
They're highly effective, described by reviewers and owners as tremendously progressive and informative. This means the pedal talks to you. You can feel the pressure building, which lets you modulate the braking input precisely.
Right up to the limit of the tires.
Exactly. They haul the car down quickly. For a concrete figure, the Dino needs only 108 feet to stop from 60 miles per hour. That level of balanced, communicative braking really contributes to the overall feeling of dynamic totality that the Dino provides.
We've established the Dino 246 GT is a dynamic masterpiece, but now we have to confront the reality of owning a steel-bodied, high-performance Italian car from the early 70s. This is where the romance meets the repair bill, starting with the #1 nemesis.
Rust. For the steel-bodied 246 GT, corrosion isn't just a cosmetic issue, it is the single most significant long-term concern, and the main driver of restoration costs.
Why was it so bad?
Because this was a high-volume, cost-conscious application of steel, the rust prevention was, well, rudimentary compared to modern standards.
And where does it typically hide?
The Dino has a complex tubular steel chassis, which is partially concealed by the bodywork. Moisture gets trapped in several critical areas. You have to inspect the outer and inner sills. Those are structural load-bearing parts. The rear wheel arches and bowls are notorious. And critically, the floor pans where they meet the longitudinal channels are often dissolved by hidden moisture.
So if the rust is bad in the sills, does that compromise the integrity of the whole car?
Absolutely. The sills are the backbone of the chassis. When corrosion takes hold, the structural rigidity, the very thing that makes the handling so good, is severely compromised. Ground-up restoration is often the only fix.
And that's not cheap.
We're talking deep into six figures. If you see a beautiful Dino, you have to assume there's potential for hidden, costly rust underneath.
Okay, let's move to the mechanical side, the timing chains and fluids.
Right. The V6 uses 2 timing chains to drive the overhead cams. Generally, these are more durable than the rubber timing belts on later Ferrari V8s.
The ones that need constant, costly replacement.
Exactly, but they're not maintenance-free. Noisy or under-tension chains are a clear, audible signal that a costly repair is needed. Ignoring them leads to catastrophic timing failure. And beyond that, frequent oil changes are vital every 3,000 miles, along with routine checks of the valve clearances.
Now for the most dramatic detail inside the engine, the valves. This sounds brilliant on paper, but terrifying in reality.
It is a classic example of cutting-edge 70s racing tech becoming a major ownership liability today. The Dino V6 exhaust valves were originally sodium-filled.
From Formula One and aircraft engines, right?
Yeah.
To dissipate heat.
Exactly. The liquefied sodium inside the hollow valve stem acts as a thermal conduit, transferring heat away from the hot valve head to the cooler valve guide.
So they were designed to run harder and cooler. What's the ticking time bomb?
Age and material fatigue. As these valves age, the stem material becomes brittle, and failure of the valve head is a real and present risk.
And if a valve head breaks off at 7,000 RPM?
It leads to instantaneous and catastrophic engine damage. Piston damage, cylinder head destruction, possibly total engine loss.
So proactive replacement is basically essential.
Absolutely. Because of this risk, virtually every dyno specialist strongly recommends replacing the original sodium-filled valves with modern, high-quality, solid valves during any major top-end rebuild. It's a non-negotiable expense for reliable ownership.
Moving from mechanical failure to electrical annoyance. You wouldn't be a 1970s Italian car without electrical challenges.
Indeed. The electrical systems are a well-known weak point. Specifically, the Dynaplex electronic ignition system, which was very advanced for its time, can be notoriously temperamental today.
Can it be fixed, or is it usually replaced?
It often needs a knowledgeable, classic Ferrari specialist. Many owners either have the original system refurbished, or they opt for modern electronic upgrades that are housed discreetly inside the original distributor casing.
To keep the stock look, but get a reliable spark.
Exactly. And beyond the ignition, you have the typical Italian electrical gremlins, gauges that flutter, power windows that stop mid-roll, temperamental switches. It just requires patience and a good wiring specialist.
Finally, let's revisit the cooling demands. The V6 runs hot, so the cooling system has to be perfect.
Maintenance here is paramount. The V6 generates a lot of heat, and since the radiator is front-mounted, the system has long runs of pipework. This makes it susceptible to blockages, low coolant, or a failing thermostat.
And failure here leads straight back to those catastrophically expensive aluminum cylinder heads.
Precisely. Overheating risks warping them. Regular coolant flushes are absolutely necessary. Owners have to monitor the radiator and the long hoses constantly. An ignored leak can rapidly spiral into a catastrophic engine overhaul.
It's an engine that demands proactive, expert care.
without a doubt.
So we have a car that is structurally vulnerable to rust and has a beautiful but complex engine with a major failure point, yet it's almost universally adored. The contrast is astonishing. Let's pivot back to that enduring appeal. The design.
The Dino 246 GT is a triumph of aesthetic design. It's celebrated for its sensual, organic curves, created by Pininfarina's Aldo Broverone and Leonardo Fioravanti. The sources consistently hail its aesthetic execution as visual perfection from every single angle.
It seems to have transcended car design and become automotive sculpture.
It truly has. It is consistently hailed as one of the most beautiful creations to ever emerge from Maranello, earning its place among the 10 greatest Ferraris of all time, in many sources, even though it didn't wear the badge at first.
And when we talk about maximizing that desirability today, two optional features dominate collector conversations.
Yes, the legendary chairs and flares package. This combination is highly sought after and dramatically increases the car's desirability and value.
So what exactly are the chairs?
Chairs refers to the highly desirable Daytona-style seats. They were an optional upgrade with a specific, more elaborate, stitch pattern-thin horizontal bars or pleats, making them distinct from the standard seats.
And the flares are the visual muscle.
Exactly. Flares refers to the metal flares that widen the bodywork around the wheel arches. These were introduced late in production, especially popular on US and British versions. They were designed to accommodate wider Campagnolo wheels and tires.
I want to clarify something we discussed earlier. The wider rear track on M&E series cars was standard, but the flares were purely an optional aesthetic and tire enhancement.
That's the key distinction. The internal engineering improvements were standard running changes. The flares were an optional cosmetic and performance package that enhanced the outward aggression and fit wider tires, but they weren't tied to the fundamental chassis geometry change.
Okay, let's put the Dino's performance in context with its rivals.
The sources are very clear. The Dino is not a supercar based purely on acceleration. Its 0 to 60 time was good, but not earth-shattering compared to, say, a contemporary muscle car. But its combination of lightweight, supple ride, and fundamentally balanced handling made it special compared to rivals like the Porsche 911S.
Which is probably faster off the line.
It was. But the Dino's superior handling and aerodynamic body meant it excelled at maintaining acceleration and stability at high speeds. This is a crucial detail. While a 2.4-liter 911S might have been quicker over the standing quarter mile, the Dino reached 120 miles per hour faster.
So that top-end pull, aided by the Pininfarina shape, helped it triumph where sheer low-end horsepower wasn't the defining factor.
Exactly. It was built for sustained, high-speed touring and cornering confidence.
It was the totality of the experience then. The sound, the comfort, and that ability to maintain speed. Which brings us to our final three essential defining points for the 246 GT.
Based on this deep dive, 3 essential takeaways emerge that really define its legacy.
Takeaway 1, mid-engine driving totality. The car's architecture is its superpower.
Absolutely. The transverse rear mid-engine layout results in outstanding balance, light and precise steering at speed, and that unique characteristic of tightening its line under power. It makes it one of the most confidence-inspiring, dynamically rewarding sports cars of its entire era.
It's a quintessential driver's car because the chassis works with you, not against you.
That's it.
Takeaway 2, the V6 legacy and sound. This is the historical and visceral reason for its existence.
It established Ferrari's first mid-engine road car lineage, paying tribute to Enzo's son. And it proved that the V6 engine, with that high revving capability and glorious savage howl near 7,800 RPM, was fully capable of delivering a defining, visceral Italian sports car experience, whether it wore the full Ferrari badge or not.
And finally, the necessary reality check.
Takeaway 3. Maintenance reality and hidden flaws. Despite its racing pedigree and the robust cast-iron block, the steel-bodied 246 GT demands meticulous, expert, and costly care.
Primarily due to the severe rust potential in critical areas like the sills and the non-negotiable need to proactively address aging engine components, especially replacing those catastrophic sodium-filled exhaust valves.
Ownership requires deep pockets and a high level of technical awareness.
It is a machine of dazzling beauty and groundbreaking engineering, but one that relentlessly demands respect for its age and its inherent vulnerabilities. The Dino 246 GT, it broke new ground, shifted Ferrari's design philosophy, and proved a V6 could achieve aesthetic and dynamic perfection.
It is in every meaningful way, from its race-derived engine to its Pininfarina curves, a classic Ferrari, even if it took the world a little time to acknowledge it. A car worth the obsession.
A timeless masterpiece.
Yeah.
Comment which classic next.